Greetings all. It's a rainy day out there, and I thought I'd talk about the importance of a good solid power supply to your hi-fi amplifier screen grids. Now I'm talking about pentode wiring, of course, not ultralinear or triode. That's a completely different thing. Well, we know the screen grid accelerates the electrons headed out towards the plate of the vacuum tube, but it also provides a lot of other improvements to the situation of the tube besides linearity and some other things. So I'm working on a new project, and it has an interesting wiring diagram to it. Actually, I'm going to reproduce another audio note, this time a P2SE single-ended. That's parallel 6L6, 2 in each channel. But they used an extra tap on the transformer of 244, 244 to supply the power to the screen grids, which is a good idea, because what happens in an amplifier, any amplifier, you're going to have a little bit of sag on transients on your B+. So if you come with a generally accepted way of hooking screens, some of them come right off the B+ itself through a screen grid resistor. Some have a dropping resistor and maybe some extra capacitors there after to try to keep things a little smoother. But when you have a sag in your B+, guess what? You're going to have a little bit of sag on your screen grids. And that's going to change the linearity of the tube. It's going to change the whole character of the tube. You don't want modulation on the screen grid, especially if you have a little bit of ripple in your power supply. That's definitely a no-no because it's going to affect the plate. The screen grid will actually affect the current in the plate. Now, in the 1937 RCA tube manual, I have a statement here that says the screen grid actually becomes the anode while the plate becomes a secondary anode. The operating voltage of a screen grid has a large effect on the plate current. So you see, if you have just a little bit of variance or modulation in that screen voltage, it's going to affect the tube. Now, there's a good article. I'm going to give you a link to it. And it's over at ostex.com. A fellow by the name of Dennis Grimwood has a really good, it's a lengthy article. I'm not going to get into all the specifics because you'd have to do a whole video. But read it over and study it and why this is important to have a regulated screen grid in your vacuum tube. Now, Dennis states it this way. Let me read you a quote that he has on his website in that article. It says, the screen grid creates an electrostatic shield between the control grid and the plate, minimizes the capacitance between the control grid and the plate, controls electron flow in such a way as to make the plate current practically independent of plate voltage over a certain range of parameters, controls plate dissipation, increases tube amplification, and in case of a power tube, increases power output, prevents feedback between the control grid and the plate, prevents unwanted oscillations of one type or another, focuses and accelerates the electron flow from the cathode or filament to the plate. It controls the electron flow to an extent more than available from a single grid tube. So you see, any fluctuations in the screen grid voltage will change the character of that tube output circuit. So when you are manipulating voltage there, it controls the plate voltage, which is interesting. I don't know if that many have thought about that, but it does bring up the question of trying to find the best screen voltage for your pentode amplifier. Now, I've built a number of different amplifiers. I've built ultralinear, I've built single-ended, I've built amplifier that already has screen grid regulation on it. It was a little L84. It worked out pretty good. But you got to look back in the early days of audio, late 40s, early 50s, when the manufacturers were looking towards making better audio amplifiers. One of the famous known circuits, of course, was the Williamson, and that was a triode. But because of price points, for those manufacturers to create something with regulation on the screen for a pentode operation really would not get past the bean counters. So you have to look at what Helfer and Kuros did with the Acrosound. They came out with those ultralinear transformers that they designed. Actually, they weren't the original designers, engineers for that. They built on someone else's work. But a lot of manufacturers used Acrosound's transformers because it was a much cheaper way to provide a better amplifier than using regulated screens on a pentode. They knew this. And there were a number of manufacturers that also designed their own transformers in-house. I think Macintosh was one, Quad was another one that they built their own transformers. But also, Acrosound made these transformers available to anybody. And so a lot of people were, especially home builders, there was a lot more of that going on back then. They would replace their transformers with the Acrosound ultralinear, and was a vast improvement. But you can achieve really good results with a regulated screen on a pentode. Now, I wanted to show you real quick on this amplifier that I'm starting to work on. They used, like I mentioned, they used a separate tap on a transformer. It was 244-0244. Now, looking at Duncan Amp's power supply modeling software, let's look at that. The 6L6, according to the data sheets, a single tube, minimum signal, a screen pulls about 2.5 milliamps. And at maximum signal, which of course most people aren't going to crank it up all the way, you have a 7 milliamp, or 6 or 7 milliamps. Let's go with 6. Now, in this power supply module, this is the one out of the Soros, because it has the same setup basically as the AN P2SE. The Soros unit has a RC filter they're using in the diagram. Now the P2SE has 100 microfarad capacitors on the diagrams that I found, but the Soros has 220 microfarad caps and 2 parallel 2.7K resistors, which works out to 1.35K, and then another 220 microfarad capacitor feeding the screens. So let's look at the voltage available. At 2.5 milliamps, 4 tubes, that's 10 milliamp. So putting a 10 milliamp load on that circuit, you can see where the voltage stands on the chart here. I have it circled in red. And if you were to increase that to a higher current rating, you'll see some voltage drop. Now, if you look at the second chart, which has a current draw of 28 milliamp, you will see a voltage drop there between the 28 milliamps or 24 milliamps, excuse me, and 10 milliamps. There's a 26 volt difference. Now, of course, you won't see that drastic of a swing in an amplifier because it's not going to be run in maximum signal. It's going to be at a lower value, but still, that can modulate the screen 5, 6, 7 volts, 10 volts, maybe on transients, and that's going to actually change the character of the tube. So that's why it's important for your screen grids to have good, solid, regulated voltage. Now, I'm still going to regulate this voltage. Actually, on this amplifier, I had a special transformer wound with the same taps that AN used, and I'm still going to regulate that. So I think it'll actually make an improvement. Also, I'm going to put a choke in the B plus supply for the rest of the circuit. That's going to show a little bit of improvement. But then again, there's a price point these manufacturers have to meet, and they can't make things too difficult. They keep it simple, less problems, less repairs on any of this equipment. The more complicated you make it, the more problems you can have. So the link again for that article, I stress that you read it over at Ostex, is on the screen here. I'll put it in the description. It's a very good article. I discovered that some years ago, and it's there's a lot of good information over at that website on vacuum tubes. So you might want to look up some of the other articles that he has up there if you haven't already found it. So other than that, I guess I'll go enjoy this rainy day. So have a good day and go build something.